everyone. Welcome to today's session on shifting left with headless testing. My name is Alyssa Leiden. I'm one of the in-house experts on headless testing at Sauce Labs. And my goal for today's session is to show you the benefits of headless testing as part of a larger continuous testing strategy. I'll start by outlining some of the industry trends that we have seen that have led to the rise of popularity in headless browser testing, especially among developers for early pipeline tests. I'll then discuss the strategy. Where exactly should we be incorporating headless browsers into, again, our larger continuous testing strategy? And then finally, I'll end with some use cases that we've captured from some of our users in the market who have seen great benefits in incorporating headless browsers early in the pipeline for fast feedback, which really helps accelerate their release velocity, improves quality, and enhances the productivity of not just their developers, but also their testers throughout the pipeline. So if any of you here have ever consumed any piece of Sauce Labs content over the past couple of years, you should be very familiar with this image of continuous testing. But I really think it's important to start here as a jumping off point, just because I want us to understand what continuous testing is and how the term shift left plays into that, because they can be seen as very synonymous, but they're also quite different. So continuous testing is a best practice approach to testing that's best illustrated in this infinity loop here in front of you. It's all about incorporating more testing earlier and more often throughout the pipeline, helping you catch and remediate bugs a lot more quickly and efficiently. And so shift left is a subset in my mind of continuous testing. Shift left is just delivering on that idea that in order to be most resource efficient and in order to accelerate release velocity, you need to shift your testing left or incorporate it earlier in the pipeline. Continuous testing incorporates every touch point of the pipeline for testing. Shift left is specifically talking about early pipeline testing. And the best way to think about shift left is to understand that as organizations realize that catching bugs earlier is both efficient from a time perspective, a resource perspective, but also from a cost perspective, it means that testing is now moving closer to the developer. And there are a number of trends that are helping accelerate this shift for a lot of organizations and really making that case for early pipeline testing. So you think of this as a cause and effect. So what are the processes that are changing and what are the tools that are presenting themselves in the market to help address these process changes or these thought changes? The first is quite simple, is that DevOps methodology and continuous testing in step with it are asking developers to test more early and test more often. And this is evidenced by the fact that the earlier you can catch bugs and the sooner you're able to unearth issues in your code or in your applications, the easier they are to fix, and this saves the organization time and money. And so since developers are being asked to test more, we're seeing a rise of developer-friendly testing frameworks specifically for JS, such as WebDriver.io, Nightwatch.js, essentially frameworks that developers can speak the language of and helps ease their transition into writing tests as part of their workflow, make it a little bit more easier for them. The second is that React and Angular are really showing themselves as being the most popular frameworks for a lot of front-end UI developers to build applications with. There's a lot of opinions that show that this is really the future of web development. And so as a result, with these two processes really starting to become ingrained at the development level, we're starting to see the rise of integration testing, testing Angular and React components very early on in the testing lifecycle. And that's just because unit testing doesn't catch any sort of bugs related to React and Angular on its own. And so the next slide will talk into a little bit more detail about how this is influencing testing pyramids or testing strategies. But it's important to understand that at the component level, we're seeing a need for more testing. And so it's really leading to the rise in the volume of integration tests. And then finally, as we look at what makes the most sense to check if JavaScript functionality is working early on, it seems that Chrome is emerging to be the best first check early on in the pipeline. You'll note that a few months ago, Microsoft recently announced that they'll start developing their Edge browser on the open source Chromium platform. And so it just goes to show that the market is really moving towards Chrome kind of eating the world. Obviously, you still need to check across every browser, including Edge on its own. But Chrome is becoming a good first choice for validating functionality early on in the pipeline. It's the leader today, it's only growing. And so the tool change here, it really leads us to wonder how we can optimize testing earlier on by using a lighter infrastructure that doesn't necessarily need full cross-browser compatibility. And this is what we're going to focus on in the second half of this tech talk, trying to find the best solution for these changes and these requirements, providing something that's lighter weight and cheaper and more cost-effective for developers to validate just functionality early on in the pipeline, irregardless of having cross-browser compatibility. This shift in processes and thinking about tooling changes is starting to change the way we think about the overall holistic testing strategy. So pictured in front of you here first is a very traditional testing pyramid. We've seen a lot of iterations of this, but essentially it's heavy on unit tests at the bottom. And as we move up, we see component tests, integration tests. When you start putting things together, might throw some API tests in there. And then at the top, you see the end-to-end tests and manual exploratory testing or live testing. The one thing this pyramid doesn't do is it does not take into account the usefulness of tests at each step or the infrastructure or dollars required to run these types of tests. And the fact of the matter is the developers are writing a lot of unit tests today, and it's really easy to write these with the tooling available. And developers are always going to run unit tests locally. Anyone with a laptop is able to spin up these tests and get feedback pretty quickly on unit tests, and that's not going to change. But as I mentioned in the previous slide, with some of the changes we've seen in the market and testing shifting more and more left in the pipeline, integration and component tests are really starting to become more valuable because they tell us if things work as expected. And to run these types of tests, you're going to need a similar infrastructure to what end-to-end tests require. You'll need a browser rendering. You might need virtual machines to spin them up. And Sauce Labs has provided that sort of infrastructure for our customers for over 10 years. But this new pyramid, or really it's a trophy, which I've attributed to Kent C. Dodds, who writes a lot of great blogs and articles on the topic, is that instead of testing the smaller pieces at the unit level, it's not super useful once everything starts coming together and integrating. It becomes more interesting when you start putting these things together. Maybe you're putting your front end together, but you're mocking your API, and now you want these two components to work together. This is essentially the concept of code from one team is now merging with that of another team. And this is a pretty useful thing to do early on in the pipeline to try and figure out if there are issues now, rather than before we add more and more pieces to the puzzle. Of course, end-to-end testing is always super valuable and has a very specific function in the delivery pipeline, late in the pipeline, as we'll see in the next slide. But to see improved quality along with increasing that release velocity, that's the big focus here is improving that release velocity. It's really important to lean into this fact that early pipeline testing volume needs to increase. And so now you need more infrastructure enabled to support this increase in volume. So let's look at this through the lens of the pipeline. Right? So as I mentioned, well, in the past, we've really focused on increasing the amount of testing near the end of the development lifecycle, and all of these tests from end to deploy to operate are still all equally as important and have certain infrastructure requirements that we at Sauce Labs have been talking about, like I said, for 10 years now. The shift for a lot of teams is now really starting to move to the left. The end of the pipeline problem still has its own issues, but now they're realizing that if we really want to go fast and accelerate release velocity and deliver on that promise of agile, we have to focus on this post-commit box I've highlighted in red. We see in the market that now more than ever, teams are moving more testing to the developers, and they're incorporating massive amounts of component and UI tests before even merging into master and integrating with a larger application. But of course, this presents a lot of new challenges. The first, and probably the most important, is that cultural shift. And this is just due to the fact that developers aren't used to writing tests as part of their workflow. They're not used to having to think about testing as part of their key mandate. And so it's really important to get that buy-in, either from an executive level or from a cultural level as a whole, to get developers to really understand not just the value to the business and to the pipeline that incorporating testing earlier will give, but also to their own workflows and making them feel more productive in their everyday life. The second is, once you do get that cultural buy-in and you start seeing the volume of testing increase earlier in the pipeline, is that now if you're using the same tools to solve the testing problem from an infrastructure perspective, now you realize that resources that were once just for our QA folks are now being shared by development and QA. And so this is where we see teams starting to queue up and capacity starting to be throttled. And this can actually be counterproductive, as there are teams that are now waiting in line for tests to pass, which is really not the benefit of automating testing and increasing the volume of testing. We still want to be able to go fast. And this leads to the third point of context switching. For those who aren't familiar with context switching, there are a lot of great blog articles about what it is, but essentially context switching is this idea that we're working on one task, we're heads down, and we get a ping from someone else saying, hey, you need to put down this task you're working on and pick up this one. And switching between two tasks at the same time has been proven scientifically to be a detriment to our productivity as individuals and to the productivity as the organization as a whole. No one likes context switching. Developers are not immune from this. Especially in an agile workflow, developers want to be able to move from one task to the next and not have to backtrack or roll back or think about things that they thought they had already marked off of their sprint board. And so if testing does become that bottleneck because of sharing resources and because of queuing up and throttling, now all of a sudden we're asking developers to context switch. And this is detrimental to that culture shift that we really want to see in a lot of organizations where everyone understands the benefit of testing and everyone can really, again, lean into this idea and help further this cause. So because of these reasons, with the infrastructure problems and the context switching and people queuing up, a lot of organizations started looking for alternative solutions or alternative infrastructure options to help developers really scale early pipeline testing. And this is why headless browsers have been generating a lot of buzz in the development world specifically. The first thing to think about is the speed advantage. Headless browsers are typically faster running browsers. And this is just because headless browsers run without any sort of UI or GUI, and instead just gives you instant access to a bare bones browser to test against. This makes it a very fast and very cost-effective option because it's a lot cheaper to operate these sorts of lightweight browsers. But the drawback is that you're not going to get the coverage that you need. Right now, Headless only runs in Chrome and Firefox reliably, and so there are definite drawbacks there. But the whole point here is speed. I need to be able to run fast. I need to be able to do it cost effectively. The second is that because of this, it's become a really ideal choice for early pipeline testing. You're giving development teams access to infrastructure that fits the need for speed and really allows them to accept this idea of early pipeline continuous testing and really gives them the opportunity to embrace automated testing as part of their process. They won't have to lean on QA or wait for their feedback hours, maybe even days later when QA throws it back over the fence and says, hey, something's wrong, there's a bug. Instead, they can just commit code with confidence, knowing that it works. And if it does come back and say, hey, there is a bug, you're going to need to be able to fix it, it'll be easier to fix because it's in isolation. And then they'll also get that feedback immediately rather than having to wait hours or days. No one's feeling bogged down. Developers are feeling more productive, and QA is also feeling more productive because they know that the app that they're getting is well tested by the time it gets to them later on in the pipeline. So for those who aren't completely familiar with what a headless browser is, I'm just going to go into a quick schematic here of what exactly is a headless browser and what are some of the benefits and drawbacks. Traditionally on a standard or headed think in the Sauce Labs platform as it is today on a cross-browser sort of platform. Right now we have a VM in our data center. When we get a call from a test, we'll bootstrap a certain virtual machine with a GUI, an operating system, and then from that we render a browser. And what's great about this is since there's a GUI, we're able to record video, we're able to give you a full extended debugging of how the tests run and what's going on. We can give you full coverage of every browser, every operating system. It's really the Cadillac, right? You have everything you could ever possibly need. Whereas a headless browser just renders the browser itself. And on top of that, you can also host it in containers. And so really it's decreasing that latency and that time spent having to spin everything up. And it's also just giving you that fast feedback. The drawback here is that, again, since there's no GUI, there's no video recording. It's more difficult to offer rich debugging information on just a standard browser. And then finally, headless browsers aren't very well suited for end of the pipeline testing because you're not able to offer multiple different types of browsers or any operating systems outside of Linux. And so when it comes to headless, this is why it's uniquely positioned to be a great fit for that early pipeline test where you need fast feedback and limited coverage just to make sure as a sanity check that every component works before merging it into master. So those who are wondering, okay, so this is great, but where does this exactly fit into my testing strategy as a whole? No one ever navigates to your site from a headless browser, so why would we test headless browsers? And I completely agree with that. And so it's really important to understand where in the pipeline headless is uniquely positioned to add value. In the pipeline, it's really meant to be, again, early pipeline tests. So think every pull requirement in the shared dev environment should be running tests against headless browsers. That's a lot of tests if you think about it. When you think about how many developers are making pull requests, especially in an agile environment, this is happening dozens, if not maybe 100+ times a day. And so to have a lightweight infrastructure that can scale up to that sort of volume, cross-browser would be great. But the fact of the matter is that it's expensive to run a full cross-browser platform that early on in the pipeline. And so it's really all about cost effectiveness and being able to scale effectively, and Headless can provide that solution. The second is a sanity check. Again, this isn't meant to test full cross-browser compatibility. This is meant to be a check for developers. Say, hey, can I merge this and know that I won't screw anything up and we won't have to roll everything back and I'm staying hours after work or trying to debug on the weekend. It's really meant to be that check for developers to ensure that they can stay productive and commit code or commit components without slowing everything to a stop. And I already mentioned this earlier, that scalable infrastructure for shift left. The amount of testing here is massive. And so you need to have the right tool for the right problem that's going to allow your team to scale meaningfully so that testing doesn't become the bottleneck and we don't have queuing up and context switching like I was mentioning earlier. And so the other question people might ask is, well, so which tests should I run through Headless and which tests should I not run through Headless? I want to counteract this thought that there are tests that are headless and there are tests that are not headless. Every test should be run through both a headless and a standard browser if that's what makes sense for your team. But the sort of tests that, again, if we're looking for the speed and scalability advantage with Headless, which I think is where the most of the benefit is seen, you need to really prioritize tests that are very atomic, autonomous, they're very short, not dependent on each other, that are very easy to parallelize, essentially. And we have a great tech talk on this from my colleague Nikolai on some of the best practices for getting your tests to run in parallel. It's all about making them atomic, autonomous. They should exist in isolation and be able to run quickly. And they also need to be able to provide quick feedback, because that's what it's all about at the development level is does it work, yes or no? And then finally, I think I've already made this point very clear. It's all about the integration level. Early pipeline, before everything merges into master, make sure it works and find those bugs earlier and fix them faster. So let's dive into a couple use cases here. I have two specific ones that we've taken from interviews with customers and how they think about how headless tests work within their larger pipeline. So in this case, I'm a developer and I'm working on a web application. So normally we communicate some information that we think is important, but not critical, not vital. But we're communicating this information with our users in what's called a modal style dialog box. And our UX team has come back and said that they don't like this box. It blocks out the rest of the page. It requires a superfluous click or confirmation from the user. And so they don't think it provides the best experience. And so to improve that experience, I've decided, or the team has decided, that of the 17 pages that have that modal box, we're going to change 14 of them to incorporate this more convenient flyout dialog box. So the text will appear instead when the user hovers their mouse over a component. And so to do this, I'm going to code up the new flyout component. I'm going to test it in isolation, and then I'll move it to the pages where it will replace that modal style dialog. So if we're incorporating more early pipeline testing, sure, I did the unit test on my local machine to make sure that the code works. But before I place it on the pages, before I integrate, I'm going to develop a single test method that'll hit all the pages that incorporate that flyout. And so this single method, run across all 14 pages in parallel on headless browsers, I'll just be able to plug in that page number, use an element locator for that component to trigger the flyout. And so now I can run those 14 parallel tests on headless browsers. I don't need to know if it works on every browser, on every operating system. I just need to make sure in isolation it works at least just on Chrome, maybe even Firefox if I have that capacity. Before then, I merge it into master. Now later in the pipeline, we'll get that full cross-browser, cross-OS compatibility check on this same component. Again, there's no headless and non-headless tests. It's just giving that sanity check to the developer that, hey, this works as expected. Now, let's merge it into the app as a whole and see what happens from there. So here's another use case with mobile in mind. And I like this one because this speaks to another tech talk that we did in the past with my colleague Wim on the mobile testing pyramid. I encourage you to take a look at that one. I think it's really great. And one of the key takeaways from that is that Early in the pipeline, you don't necessarily need real devices or even emulators and simulators to test at the component level. You can use resized browser windows to mobile resolutions just to get that quick sanity check to keep everything moving at the pace that we need to accelerate our release velocity. So let's just say that we're working on an application that was desktop, and now we're going to optimize for both tablets and mobile. And I'm on a team that's working on the header of this page. It's updated constantly for seasonal content and just general content changes. There are a lot of developers on multiple teams that touch this header. And so as we're expanding to be mobile responsive, we want to make sure that that header and any functionality within it remains the same and has the same experience, but also uses the same code base. And so the net result of this is that the header is going to change its look and feel depending on the width of the viewport, but we still need to make sure that the same controls and options are made available in every look, even though how they present to the user is different. And so I, as a developer, need to design tests that check the same controls in the same order, no matter which window resolution I'm working on. Ideally, these tests are going to use the same code base. And so I'm going to use page objects to abstract out the click on the hamburger control for that narrow look, for example. And so if I use Headless, I'm able to run quick checks using the pre-committed code to ensure that changes that I make to the header reflect correctly, no matter the screen resolution, before merging everything into the master. So as I get ready to wrap up here, hopefully those use cases have made the case for why Headless is very uniquely positioned early in the pipeline at the developer level. But I think it's also important to call out what Headless isn't necessarily designed to do. First is the most important. Headless is not meant to replace end-to-end cross-browser tests on full browsers on every operating system. This is a different point in the pipeline. There are different challenges associated with it. You still need to make sure that your application works in every browser, every operating system. And to that point, Headless isn't really meant to run any rich debugging or replicate bugs found in production. It's meant as a quick sanity check for developers to ensure, did I break something, yes or no, before moving on to the next step. Obviously, the third point seems redundant. We would never recommend running any tests that aren't able to provide immediate feedback. But I think this really speaks to something that I brought up in the cultural point of shifting your testing left, is that if your developers aren't ready to embrace automated testing as part of their workflow, or if you as a developer still haven't bought into this idea, then you're still new in your testing journey. And so Headless isn't going to be able to provide the value that a full browser would at this point in the journey. The companies that I've spoken to who are really succeeding with Headless testing as part of their larger strategy are really advanced, and developers have really leaned into this idea of incorporating testing into their own workflow. And they're seeing that scale and that speed that Headless testing can provide. And then the fourth one, again, seems redundant, but it's important to understand that Headless should not replace the real browser tests. You can run those tests on both Headless and real browsers or headed browsers, but it's really important to incorporate Headless as part of a larger strategy with full browsers with all the operating systems. So Headless testing is still a very new topic in our industry, and so I encourage everyone to really do the homework and understand what exactly Headless browsers can provide and what they can't provide, because again, it's a very specific tool for a very specific problem. And so I've thrown up some great resources here that are all on the Sauce Labs website. The first is a white paper that goes very much into depth on what is Headless testing on Headless browsers, what are the benefits, what are the drawbacks, what are some questions you should ask yourself before thinking about implementing Headless browsers as a strategy. We also have a quicker blog post on the second bullet point here. It's quick and dirty, some of the same content, but just in a more condensed way. And then the third and fourth are both talks from our recently wrapped SauceCon user conference. The third bullet point is from an actual customer of Sauce who implemented Headless testing in their CD pipeline to great success. I highly recommend that talk. It's very illuminating. You can see some of the speed benefits they saw from incorporating Headless early in the pipeline. And then finally, the last bullet is a talk on, again, a lot of the stuff we discussed today, but going more in depth on some of the industry trends we've seen that have led to the rise of Headless, and a quick overview of the Sauce Headless testing platform, which we recently just released to our customers as a complement to our full cross-browser solution to help accelerate release velocity. And that's it for me today. You'll see my email and my Twitter handle here on this slide. I encourage you to reach out with any questions. I love hearing feedback as well. I hope this talk on shifting left with headless testing has been valuable. Thanks so much for your time, and happy headless testing.